Hi, they're gonna present my presentation on machine learning applied modern astrophysics. As a summary, I did a brief overview of modern astrophysics. Machine learning being applied in a few cases to get to know better how people do that nowadays. A few use cases where I go into more detail overview too, not in too much detail, some challenging limitations, and a conclusion. To start, we need to understand how much data we're talking about. Because we have that data about not only cosmology, astrophysics, big structures, galaxies, stars. So in that thinking, we need to realize that we need to process all the data. So to do that, a good way to go about is to thinking in machine learning not just in the case of AI, but in the automation process. Because modern machine learning is not just a way to build artificial intelligence, but a way to automate process. And how we can apply that? Few cases are categorization problems. You wanna differentiate between, something like classes, where you have it's one type of galaxy, type of stars, a simulation problem, where you wanna not only emulate how something behaves, but process all of that real data and then transfer it into a way you can simulate, like in the first example, when we think about all the structure when we have cosmology research, we have those webs, and those webs are simulated in the sense of when we have those images read the data like black holes in the middle of all the data, that's a case of resolution simulation problem. A feature identification problem is more a case of we have an object. That object has multiple features, like in a spiral galaxy, we have disks, bars, arms. All the features can be, in a way, dissected and separated in various classes. In those classes, we can teach a convolution neural network to identify and separate. And a case of more recent research is exoplanets detection, because in the case of the exoplanets, most time the data we are observing is not clean. Then machine learning can help it make sense of all that data. Like I said, in the research on planets, the real problem is we need to observe a star, and that star will have some type of interference with the object that through our line of sight. Then we can make sense of what normally would see as noise. That way, we can find those characteristics in the light that we observe from the star. Like neurometers can find the same way you can input not only what we think is the lightning tip, meaning it's formed as an exoplanet, we also can put what we would know that is real noise. That way I found an image that can help with visualizing how those AI models can be applied in that type of data. But I didn't mention, but AI is like a big area. In machine learning, we can think it's like a application of AI model because a machine learning model is a part of AI model, part of that. Other use case is when people want to find detect gravitational waves, and those gravitational waves are like ripples in the space-time. So it's a very fine and detailed type of data you wanna look for. So in a convolutional neural network, we can start programming something like a forest in which you can not only branch out to different types of noise, but when you simulate the data, clean data, we can start collecting other branches where they can be designed as noise. Each type of noise will be one type of simulation. So you can differentiate what would be a gravitational wave and what is noise. It's a better way to automate something that 8 people in laboratory will need to look manually and be able to differentiate like centimeters of line minuscule data. Another use case is to make another type of, you can say, a smart neural network is to differentiate classes. Like we want to classify types of galaxies, elliptical, spiral, and 2 minutes. And then one way to go about doing research on any type of object you want to differentiate in classes is to simulate that data. And for that, I sample some of my research in which I differentiate between a galaxy with this and without this. That's why I put it a simulation of a galaxy and a lenticular galaxy. This type of model is extremely specific to automate what someone would do. That case, I mean, I did my undergrad exactly that, but manually. Then I started automating all of the process. So, one case when you go about doing manually research, you probably would find a lot of errors in a person doing that. So in that case, the another good way to go now comes play or what I would say that it is word problem. If you think about in a timeline, we have telescopic data from telescopes since 1600. From then on, all the data we have today is a sum of everything we did, every type of hardware improvement we did in transport, all those types of data, and that we can see a lot of the data have noise and or maybe something happened when the observation was made. And a machine learning model will struggle with that because how a machine learning model is made is like we take off the same way we think about something and we build the neural network to do exactly what we want to do. So part of the problem is how we interpret the problem. Because machine learning in general is not limited to the way we think. It's limited to the way computer can process all the data. So one of the problems not only in feeding an algorithm is us not only the data or the model, because if we think about a deep learning network, it can be like branches in a tree. Every process it does, it doesn't give you what it's doing. You have an input, that input can go one branch, and if you think about deep learning, it's not just one tree, but put millions of trees. And each tree is connected to all the other trees. So it can go any way it wants to go. That type of thinking is not something we can process. So one problem with that kind of model, like I said, is how we interpret the problem. And because of that, like we introduce bias into data because we think in a way that always introduce that because most deep learning models are not supervised models. Most of them are unsupervised. And when you build that, it's not more a controllable process. You just control what you give to the neural network and what comes out of it and produce model. And then we can start giving problems to us and give small positives and all that. And conclude, machine learning is not more like an option anymore. The way we go about it doing research is not going to go the way we do things because at every evolution we do in hardware, we create more data. And that data, we can process that in outputs. So we need to create inputs. That's how it's going to be. That's not an option anymore to just do research the same way people did 20 years ago. That's a reality today. Thank you.